Area between two curves. Let's go. Warm up. So this is from the textbook. The idea between two curves is you have like an f and g, one's on top and one's on bottom. The area under a curve is usually the definite integral, right? Integrate like f of x from a to b. That gives you the area under the curve. Well, if you want to find this area between two curves, it's basically the area under f, but you have to take away the area under g. So the formula the way that we write this is the area equals f of x minus g of x from a to b, where a and b are your endpoints. And I like to think of this as the top minus the bottom. The top minus bottom is how you find the area between the curves. You're integrating the top function minus the bottom function. Now, a few things to note here. You have to find the actual area, and the area cannot be negative. So area is always going to be positive. And we'll come back to this later. Like the area is not going to have negative area. Usually if we integrate under a curve, let's say if I had a function that did this, I want to say this area, this would be negative area. But when we're talking between two curves, it's always positive, okay? So a few things that you might have to ask is, what are the left and right limits, the endpoints? Where's our a and b? Sometimes you're given these. Sometimes you have to figure them out a little bit, but you got to know where those endpoints are. And then the other question is, how do you know what's on top? So I told you f is on top and g of x is on top and on bottom because I tell you right there. But what if I just give you two functions and like I don't put a graph out? How can you figure out what's on top? What if I draw two curves? What if I drew this? This is one curve and this is another curve. And I said, hey, one of these functions is sine of x or something. And one of these functions is like 3x plus 1. And I want you to find the integral from a to b right here. But I might not tell you which one's on top and bottom. Sometimes you can just look at the picture and I go, I know what a linear function looks like and then a trig function looks like. You might be able to identify it just by the shape of it. But you might also have to plug in points. Now, as a note for this, the question is, does it really matter? And I'm going to say it doesn't, as long as you remember that the areas have to be positive. So sometimes, like, if you get a negative area, you probably put the wrong thing on top. All right. So key things here, you got to know your limits. It's the top minus the bottom, f minus g or whatever, if f's on the top. How do you know what's on top? You could do some test values. We'll show you some things. And sometimes it doesn't matter because you have to remember it has to be positive. Sometimes I like on an AP test, I would just put an absolute value. I'd put an absolute value. There, I'm right. Even if I don't put the right thing on top and bottom, as long as I put absolute value, I know it'll be fine. Works. All right. So let's take these test cases. Let's take scenario number 1. It tells you the boundaries. So here's two cases right here. We're going to focus on this left one. So if it tells you the boundaries, and let's say I had my two functions, y equals negative 1 over x squared and y equals 4. So those two cases would be, this line is going to be y equals 4 right here. And then these functions are going to be y equals negative 1 over x squared. This is like this. And then I tell you my boundaries. Let's say this one's going to be my a, my left-hand limit, negative 5. And then my b is my right-hand limit, negative 2. So negative 5 and negative 2. I say these are my boundaries, a and b, and these are the two curves. If I give you everything, let's just set up the integration. I'm not going to worry about plugging it into a calculator or anything like that. I just want to set these up. So what would that integration look like? Well, remember it's top minus bottom, so I'm going to put a note. So a to b, and it's f of x minus g of x, top minus bottom, right? Okay, so setting up this case right here, I know it would be my limits are -5 to -2 because I can see that in the picture. Now, which function's on top? Well, clearly the y equals 4 is on top. So I can go 4 and then minus the other function, which is -1 over x squared. And that would be how I'd set it up. For these problems, I'm just showing you how to set it up. I don't want to evaluate it. I don't want to deal with that math right now. Let's say I had this one on the right. Okay. So my limits, I'd be going from 0 to 4. And then one of these functions is on the top and one's on the bottom. Now, which one's -3 square root of x and which one's +2? I have this function and then this function. You might be like, I don't know. Let's say, I mean, obviously this is on top, right? Positive. But just take a test point in here. Sometimes if you don't know, take a test point between 0 and 4. Maybe take x equals 2. And then which one would be higher? This one will be higher. So that'd be on top minus the other one, -3 square root of x dx. Calling me. Don't care. That's how that's set up. All right, questions? All right, let's do scenario number 2. What if I don't tell you where they intersect? What do? So I'm going to take these two problems. I have two equations right here. Boom and boom. I'm going to say I don't know what the limits are, and I don't even know what's on top and bottom. What do I have to do to find out the limits? What I'm going to do is I have to set them equal to each other. Set equal to each other. Let's assume I don't have a calculator to graph it. We'll show the graph afterward, right? We're going to have to set them equal to each other to solve for x. So I'm going to say -x squared over 2 plus 4x minus 5 equal to +x squared minus 2x minus 5. Might need to set them equal to each other, assuming I don't have a calculator here. And so we get to do the math. Okay, this is quadratic equation. Okay, first thing, I don't know how you get there, but I don't like having fractions. So my brain says, okay, never mind. I'm going to push everything to one side. So let's say I'm going to add 5 to both sides. And then if I do that, I get -x squared over 2 plus 4x equals x squared minus 2x, because those both go away. Cool. And now I'm going to say add 2x to both sides. Those go away. Get x squared equals -x squared over 2 plus 6x. And now I want to get this x squared over here. So I'm going to subtract x squared on both sides. All right. If you don't like dealing, sometimes, you know what? I'm going to be honest. I don't like dealing fractions. Not what I'd really do. Because I feel like I'm going to mess up fraction math. I'm going to actually multiply everything times 2. I just want to get rid of this. I hate that. And then I'm going to subtract 2x squared on both sides. I'm at -3x squared plus 12x equals 0. The idea is to get it like this, isolated. Now I can use my algebra skills. Factor. I'm going to factor out a 3x, the greatest common factor. So I get -x plus 4 equal to 0. And maybe you're seeing this. Oh, Yep. This one, you set this one equal to 0. So x equals 0. Then we have negative x plus 4 equals 0. So then x equals 4. Those are my 2 points that intersect. So if we're not told limits, those are going to be the points where I intersect. So somehow these graphs, one goes like this and one goes like this, and they intersect at 0 and 4. And one's on the top and the bottom. I just drew some blob, right? So now I can set up my equation or set up my integration as from 0 to 4 of the top minus the bottom. Now here's my problem. I don't know which one's the top. So I can use absolute value, but let's say I want to figure out the top. I know they intersect only at these 2 points, so everything in between, one of them's always on the top and one's on the bottom. So I'm just going to take some random value between 0 and 4. Let's just take like 1. This is what I would do. X equals 1. So what if x was equal to 1? Or let's do the math. That's okay. If x was equal to 1, that top equation, or this guy, I guess x is equal to 1. Let me do the math right here. X was equal to 1. What would this? Let's do this one easier. It'd be 1 minus 2 minus 5. So it'd be negative 6. And if x was equal to 1 over here, that'd be minus 5. So it'd be plus 4. And this would be like negative 1/4. This one's going to be like negative 1 and negative 1/4. This one's smaller. This one's bigger. So the way I'm going to set this up is this one minus that one. So it'll be negative x squared over 2 plus 4x minus 5 minus x squared minus 2x minus 5. And if you want to see what the graph looks like, it's like this. Other things so this one is your negative x. Notice negative x squared over 2. That means you're going to be concave down. It's going to look like a sad face because that's a negative x squared parabola. And this is positive x squared, so it'd be happy face parabola. The great thing is if you mess this up and you plug it in a calculator and you got negative, you probably just you flipped it. So just flip it. But there you go. Set them equal to each other. If this was a calculator problem, sometimes that's easier with the calculator, but that's how you could do it by hand. All right, questions? All right, I'm still recording. What if they cross in the middle? So we're going to talk about this one over here, but let's look at the one on the left or the right first. So sometimes they cross in the middle. So this is where it gets a little bit more complicated. So I have 2 equations here on this right-hand side. I want to show you what they look like. You have this negative x over 2, which is a line. That's where, this is a line, so it's going to be that equation. And this one's going to be a cubic equation, x cubed. So the wavy one. But notice they cross at the middle. They actually cross at 3 points. They cross at negative 2, they cross at 0, and they cross at 4. When you have a problem like this, you are going to have to separate the integration. I can't just say, integrate from negative 2 to positive 4 and top minus bottom, because different ones are on top at different points. You have to break this up because we want to find the total area. If you try to just integrate straight across, it's not going to work. Even if you try to like absolute value it or some shenanigans, it's not going to work. What you want to do is you're going to have to split this up. So I'm going to actually integrate this from negative 2 to 0. And I'm going to have the line on top. So actually, let's do the math. Let's do the work down here. I'm going to need more room. So I'm going to have to split this up, integrating from 0 to positive. Negative 2 to 0. And then integrate from 0 to 4. And different ones are going to be on top and bottom. So for example, let's say this function right here, I don't want to write it all out. No, I'll write it all out. So for this one, it'd be negative on the left, the line's on the top. So it'd be negative x over 2 minus the other thing. I should really choose easier examples. And the other one's going to be the opposite. It'll be negative x cubed over 2 plus x squared plus 7, 2 over x minus negative x over 2. Just remember you have to split them up. So let's take this example. So there's that scenario. Let's take this one. I don't want to look at it. Let's say you're just given this. You're not given the endpoints. Now we have to figure out where they cross. So I'm going to have to set those equal to each other again. So negative x cubed minus x squared plus 4x is equal to negative x squared. Okay, I'm going to add x squared to both sides. Cancel, cancel. Negative x cubed plus 4x equals 0. So whenever you're trying to solve for x, you want to push everything to one side. All right, I can factor out an x. So get negative x squared plus 4. Just like we did last time, we set each of these terms. So we have x equals 0 for this guy. This other one is, I'm going to rewrite this as 4 minus x squared equals 0. We'll probably eyeball that and realize x would equal positive 2 and negative 2 would both work. You only put positive, I think you're killing kittens. Or no, I think it's bunnies for that one. I'll have to look up the picture. Maybe it's puppies. So now I have 3 options. I have 3 points where they intersect. I know when I set up my integration, I'm going to have to split this up from negative 2 to 0, and then from 0 to 2. Okay, here's what it looks like. So negative 2 to 0 and 0 to 2. Different ones are on top and bottom. How do you tell what's on top and bottom? Plug some test points in. One thing you know with these is they're probably going, like, it's not guaranteed that like the same function might be on top for both of them, but it's probably going to rotate. I mean, they're not going to trick you like that. And they're polynomial functions. They're not going to be weird. So maybe you figure out what's on top here. Maybe you can eyeball this and you know the negative x squared is the upside down parabola. That'd be hard to eyeball. I'd basically, if I were you guys, I'd take like a test point like x equals 1. You realize if you do x equals 1, this guy will be negative 1. And then x equals 1, this guy would be positive 2. So this guy's on top over here. Let's say negative x cubed minus x squared plus 4x minus negative x squared. And then this one would be the opposite. Negative x squared minus negative x cubed minus x squared plus 4x. That's how I'd set it up. Need a bigger tablet. I think if I had the bigger tablet, I'd write better. Whatever. Questions? One more scenario. Oh, there's none. Last little bit here. This is area between the curves if we're talking about functions. But sometimes you have functions that are like, with respect to y, they're like, I guess they're still functions. X equals, y squared minus 3y or something. It's like sideways. So another way, if you ever get these like sideways functions, it's not top minus bottom. Think of it as right minus left. It's like the positive side minus the negative side. So if ever you get these sideways things and you do this in the last part of Khan Academy, it's going to be right minus left. All right. So top minus bottom, right minus left. And again, the great way to go check this is if you end up like put one on top of the other. And if you get a negative number, that means you put the wrong one on top. All right. Okay. So here's what I'd like you to do. I'd like you to try this for me right here. Try to do this problem and solve it completely. Let's see what you get for an answer. We're going to come back in 5. I'm going to record myself doing this problem. If you want to pay attention, you don't have to. So I have 2 functions, this and this. You look at this picture right here. I know they cross at 0 and 1 because they tell me my limits are going to be from 0 to 1. And I go, what's on top? Well, you can plug in values, but this is a line. This is a curvy boy. That's a parabola. Parabola. That goes on top. Minus the bottom. So I got this. Great. Now I'm going to anti-derive, integrate. X cubed over 3 plus 2x minus x squared over 2 from 0 to 1. And then you plug in 1. I get 1 cubed over 3 plus 2 times 1. Uh-oh. Yes. Oh my God. That's an awful 2. That I thought that was a 3 as well. I gotta practice. I'm bad at writing. Minus. Calm down. 0 cubed over 3 plus 0 plus 0. Why am I even writing that out? Now, if this was a free response, I'm circling this answer. But we're going to be big kids here. Try to simplify. That's going to be 1/3 plus 2. This will be minus 1/2. And then we're like, oh, fraction math. How do we even do that? You got to make the same denominators, right? So this is going to be 6 would be the common denominator. So this will be 2 sixths. This will be 12 sixths minus 3 sixths, which is going to give me 7 sixths. Sixths. And then you play this, and then you play the Khan Academy sound in your head. I should get that on my soundboard. I don't have it ready. Go do your Khan Academy. Bye.